Hi, welcome to AB Video 3.5 Part 2, more on limits at infinity and horizontal asymptote. Okay, you have to keep in mind, remember when we used to do substitution with limits and we got 0 over 0 and then we'd factor or simplify or rationalize, and remember how our answer ended up being 3 sometimes, or negative root 2, or does not exist, or 0. It's what's called an indeterminate form. It means that when you substitute and you get 0 over 0, your answer really could be anything, and there's a process. Now, before we go any further for this next example, this is the only tough example in the whole section. You have to keep in mind that although you would like to think that the square root of x squared is x, that's simply not true. The square root of x squared is the absolute value of x. For example, the square root of 5 squared is the square root of 25, which is 5. So here you would think, oh, I don't need the absolute value. But if I had the square root of negative 5 parentheses squared, when I square negative 5, I will get 25. The square root of 25 is 5. It is not the x, which was the negative 5 I started out with. Okay, so now that we've accepted that, here's a very difficult situation. This is not a rational function. It's a combination rational radical function. This square root is going to throw, it's a big problem. Okay, now, its limit as x goes to infinity. So I'm going to go back to that other process we talked about, which was multiplying top and bottom by 1 over x to the highest exponent we see. The degree of the numerator is 1. In effect, the degree of the denominator, being the square root of an x squared, is 1. So I'm going to multiply top and bottom basically by 1 over x. Now on the top, I am going to multiply it by 1 over x. On the bottom, I can't multiply a radical with a non-radical, so I'll multiply it by the square root of 1 over x squared. This x right here, the only reason that is x is because this is x approaches positive infinity. And the square root of x squared, which is what I'm putting up here, is equal to the absolute value of x, which is x if x is positive and infinity is positive. So now what happens is I distribute. I get 3 minus 2 over x. Here I'm multiplying through. I have the square root of 2x squared plus 1, and I'm multiplying through by the square root of 1 over x squared. If I put it all together, I have 2x squared plus 1 over x squared. Split it up, I have 2x squared over x squared plus 1 over x squared, and 2x squared over x squared is 2. And then I'm left with the plus 1 over x squared. Now remember, as x goes to infinity, these two fractions, because they're a constant over x to a power, positive power, are going to go to 0. I'm left with 3 over the square root of 2. Therefore, if they were to ask, that implies there's a horizontal asymptote of y equals 3 over root 2 at the far right end. Now I know at this point you're thinking, hey, the degree of the top is 1. In effect, the degree of the bottom is 1. Can I just do leading coefficient over leading coefficient and get 3 over root 2? Well, wouldn't you think so? But that's going to fall apart if it's the limit as x approaches negative infinity. Because what happens, I have the exact same expression. So again, degree of the numerator is 1. In effect, the degree of the denominator is 1 because it's the square root of x squared. So I'm going to multiply top and bottom by 1 over the square root of x squared. But on the top, the square root of x squared is not x because x is going to negative infinity. And remember, when x is negative, the square root of x squared is negative x. So that's where that negative comes from. Now I'm going to distribute. I'll get negative 3 over plus 2 over x. Here I'll have 2x squared over x squared, which is 2, and then 1 over x squared. All of that's in a radical. As x is going to negative infinity, both of these fractions will go to 0, and you'll see I get an answer of negative 3 over root 2, not positive. And this implies that at the far left end, I'm going to negative 3 over root 2. So this is a very interesting graph that you have because graphs do not always approach the same horizontal asymptote at the right end as they do at the left end. Now the other thing about horizontal asymptotes is a graph can cross a horizontal asymptote. A graph can never cross its own vertical asymptote unless you're talking piece function. because that x value is not even in the domain. But a horizontal asymptote is the behavior at the far right end and or at the far left end, and has really nothing to do with what's happening in the middle. To check if it does cross the horizontal asymptote, and that's really a question mark that you're asking yourself. Let me take blue. Okay, so you're asking yourself, does it cross the horizontal asymptote of y equals negative root 3 over 2? So what you do is you go back to your equation, which was y equals 3x minus 2 over the square root of 2x squared plus 1, and you set that equal to that horizontal asymptote value and try and solve. It so happens in this particular case that you do get a solution, and that x is equal to negative 1 over 24. So there is actually a spot where this graph is going to cross over this horizontal asymptote, but at the far left end it's going to have to approach it. Okay, as far as the y coordinate, you would plug that negative 1 over 24 into the original function, which was this. Okay, if you look at the book at number 4, okay, it's match the function with one of the graphs. So it's basically, if you look at the horizontal asymptotes, it actually tells you to do that. So you'll notice this one has a horizontal asymptote of y equals 2. Looks like this one's y equals 0. It's a little offset here. It should be lowered a little bit. This one at the far right end has a horizontal asymptote of y equal 2. At the far left, y equal negative 2 looks like. This one looks that at both ends it's approaching 0, one from above, one from below. Limit as x approaches negative infinity, looks like it's approaching a height of 2. Same thing on the far right side. Notice the graph does cross it there. And here, the limit as x approaches infinity seems to be approaching a height of 2 on both sides. So looking at these expressions, if you look at number 4, the one we were looking at, without the plus 2, the degree of the top is less than the degree of the bottom. So the horizontal asymptote for just this fraction would be y equals 0, but you're pushing that up 2. So first of all, that would be on either side, because this is just a regular old polynomial function. So it can't be this one, because that does not approach a height of 2 on both sides. Neither does this one. Neither does this one. But it could be either this one, or this one. Okay, so in order to make that decision, first of all, you'll notice this contains the point 0.2. This contains, looks like the point 0.5, and this one contains the point 0.0. If I replace x by 0, I get 2 plus 0 over 1, which is 2. So I should have a y-intercept of 0.2, so most likely it's that one right there. Okay. Whoops. Oh, doing limits at infinity on your calculator, very, very easy to do. So you're going to use your template, you're going to use the limit thing, and then you're going to have the limit as x approaches, let's say negative, let me make that sure that's negative. Infinity is in where the pi is. You wouldn't approach infinity from the right or left, so that wouldn't be the case. And let's say I had the fraction, I don't know, 3 over x squared. Okay. Okay, so you just press enter, and voila, there's your answer. So very easy to do, which means if you wanted to try some of the trickier infinite limits at infinity questions, and they were even questions, then you don't have the answer at the back of the book. You could actually just use your calculator to do that. Okay, now this next one is weird, okay? What is the limit as x goes to infinity of sine x? Now here's the graph of sine x. And as you can see, the graph of sine x really does not approach any particular value as you keep moving on to the right. It just keeps bouncing up to 1, back down through all the values till it gets a height of negative 1, back up through all the values until it gets to 1. So it's not approaching a particular number. However, the limit as x goes to infinity of sine x over x, if you think about it, no matter what x is, sine x is some number, as we said, between negative 1 and 1. And what we would have is some constant between negative 1 and 1 over x, which is infinity. Well, a constant over infinity will give 0. And sure enough, if you were to graph y equals sine x over x. Let's actually do that. Y equals sine x over x. So I'm going to do the fraction. Sine, actually, let me just use their sign. Sine of x over x. Now this is a trig, so I'm going to do a menu 4, and I'm going to do a zoom 8. So just press the letter 8, the number 8. Oh, that didn't work so well, and that's because I'm in the wrong mode. Doc 7.2, I am in radian mode. Well, then let's just go back to a normal old standard viewing window. What is happening? Did I not just enter this function? Am I losing my mind? I could have sworn I just entered that function. Okay then. Okay, so we have sine x over x. Let's just press enter. Alrighty, so as you can see, now it's not a great graph, so I want to see it further out right and left. So I'm going to just do this, and I'm going to let it go from negative 50 to 50, just so you can see. And we don't need to go as far up and down as negative 6.6. Let me just have it go from negative 2 to 2 as far as height goes. Okay, and here we go. All right, so this is a much better graph. So you can see it's like it goes up quite high, and then it comes down, and then it just kind of levels off. And you can see that as you move to the right, the heights of all the points are getting closer and closer and closer to 0. Okay. There is there's a point discontinuity here because, of course, at x equals 0, you have 0 over 0, which doesn't exist. But you should know, and this is from before, remember that we know that the limit as x approaches 0 of sine x over x is equal to 1. And that's why there is this point up here of 0, 1, which is an empty dot.